Hey folks, and welcome back to CS1322. This is going to be lecture number 7, and today we are going to talk about everybody's favorite topic, polymorphism, which is one of those words that is just going to keep coming up in your life during interviews and, generally when you are talking to people about object-oriented. It's one of the most important concepts of object-oriented programming insofar as it allows you to use things in ways that are a little bit unusual, and that's what I'm going to hopefully explain a little bit about today. So to start off, we're going to go over what is polymorphism. We're going to do a quick review of what we covered in the last lecture about inheritance, and then we're going to talk about dynamic binding or late binding, which is really what polymorphism is. And as I mentioned, this is an important topic. People are going to keep bringing this up in interviews. So when you go in and you're taking your developer interview, it is very likely that somebody is going to write some code on the board and ask you, is this an example of polymorphism, and why would you ever do this? So it's super important that you understand this concept, not just because of the quizzes and the tests that are upcoming, but also just in general so that you are well prepared for your interviews. All right, so let's begin with the actual word polymorphism, which is a fun word to say multiple times in a video. The first part of that means poly, which means many, and the second part of it is morph, which, as you might have guessed, means different forms. You've probably heard of the concept something morphing from one form to another, and that's exactly what we're going to have here. You're basically allowing a piece of code to change how it behaves as it is running. And that's really the key point of polymorphism. So if you get nothing else out of this lecture, understand that we are allowing code to change in runtime as opposed to in compile time. So we're going to do a couple of examples, and I'm going to explain that to you. So how does this work? So let's talk a little bit about inheritance, which we spoke about in the last video. So hopefully you watched all hour and a half of lecture number, lecture number 6, I think was the last lecture. So if you've watched the hour and a half of lecture 6, then you should be familiar with the concept that overall inheritance talks about taking data from one object, one class, and when you instantiate the child, you inherit all of the properties, all of the methods, variables of the parent. I'm going to pause the video because it is doing the weird flashy thing again. I'll be right back. Apparently I just needed to change position, so now all of a sudden it's not flashing. Yay! All right, so let's go over that again. So if you have a base class, and the base class has a bunch of variables and a bunch of methods, and you inherit from that base class, then the child is able to call all of the methods of the parent and probably be able to see many of the variables. And again, there is scope in there insofar as you have to understand if the parent had marked it as private, then the child is not able to see it. But many methods that the parent might have would be available to the child. And that is all the public methods and all the protected methods. Okay, so that's inheritance. You're taking something from your parent and you're being able to use that directly as a child. You also have the ability to override it, and we've talked about that before, where you might get a method from your parent that, as your particular code, what you need to do as a child, you may need to behave slightly differently than the parent did. So a subclass can always override, or as the slide says here, redefine a method that it inherits. So let's take a look at another UML. So this is the same one that we looked at the last lecture. We have the mammal parent class, and in this example, we're just saying that the mammal has two methods, eat and toString. ToString in lowercase here because we're looking at Java. If this is in C#, then the T would be capitalized. So mammal exposes two methods. They're both listed with a plus sign, and you'll remember that tells you that these are public methods. So any child that inherits from this mammal would be able to call eat or toString. So a mammal eats food. Great. That's pretty generic. Doesn't really mean a whole lot. So the first thing that's going to happen is we are going to make a class for a dog, which, as you can see from this arrow, that dog inherits from mammal. So a dog is a mammal. That's the relationship. And likewise, we also have a cow, and a cow also inherits, so therefore it's fair to say a cow is a mammal. So before we write any code, we could immediately call eat on a cow once we've instantiated the cow, and it would attempt to do whatever the mammal does, which is it would allow it to eat food. But as you might guess, cows and dogs eat slightly differently, so what we would probably want to do is we would probably want to override the eat method in both dog and cow to do the thing that is specific to that subclass. Okay, so this was mostly a review from the last lecture. I've said all this before. Really, you're inheriting information from your parent, and that gives you the ability then to override it if that's what you're needing to do. So how is this polymorphism, and what does that all mean? So we're going to start off with instantiating a mammal. This is from this previous UML that we were just looking at. So we're going to say mammal M equals new mammal. And that's exactly how we've instantiated classes this entire time. Every time that you've done something in Java or C#, you have said a class name, a variable name gets new class name. It has always been that the type of the variable and the constructor call have been the same. Polymorphism is going to bring up a concept where they don't have to be the same. They do have to be related, but they don't have to be the same. Okay, so this first line of code, we're instantiating a new mammal. And I think as we said in the last slides, that's kind of weird. I'm not really sure what the heck an actual mammal would be if we instantiated one, because it's just a generic kind of concept. But sure, for this circumstance, that's what we're doing. In the next line of the code, I'm going to change what M is. So this M is the same, those two are the same variable, but I'm going to magically say M gets new dog. Okay, what just happened here? So why did it let me do that, and what is actually going to happen? To be clear, the type of M is listed as mammal, which is our parent, but I just instantiated a dog on top of this variable, and it let me do it. The only reason it let me do it is because dog is a child of mammal. There's a relationship there, so it understands that that is permissible. I can also, a moment later, change it to a new cat, presuming that there's a cat class, which is also a child, new cow from the previous UML. So right here inside the code, I am changing the meaning of what M is. It started off as a mammal, and it would have only had access to the methods and the attributes that were public in mammal. But then a moment later, I made M into a dog. I changed it, hence polymorphism, because I am changing what it means. It is now looking like something else. I have shape-shifted it, if you will, from being just a generic mammal into being a dog. The reassignment of M to being a dog is polymorphism. The reassignment of it going into a cat is also polymorphism. These two lines can actually be combined. You could also have said mammal M equals new dog, and that would have accepted and been fine. So this is polymorphism. I am allowing a class type mammal to contain a dog, which is a subtype of it. I have effectively morphed M from a mammal into a dog, or from a mammal into a cow, or from a mammal into a cat. The moment that I did that was not during compile time, and that's a very important distinction here. I'm able to do this inside of my code, and this could be inside of a condition. I could have, if something is true, then M becomes a dog. If something else is true, then M becomes a cat. That means at the time that the compiler compiles your code, it doesn't actually know what is going to happen. It doesn't know what type that is going to be and what methods are going to be available. It only knows that when you actually get to that part of the code. And again, that's an inherent part of polymorphism here. So there's another word for this, what we just described. It's called late binding. And it's called late binding because it's not happening during the compile, it's happening in runtime. It's happening as the program is executing. And again, the reason that this is a distinction, like I obviously wrote the code before I compiled it, the code was in there, but the compiler has no way of knowing which block of an if statement is going to be true at compile time. So it's allowing you in the code to change the meaning of M in real time as it's running. So this is called late binding, and it is something that you probably just need to get used to that word. It is binding the type not at compile time, but at runtime. That's what's making it late. If it was done in compile time, it would be called early binding, which is what you have here. But that's not true here. In this case, it's happening later as you actually are running the program. So hopefully that makes sense. So late binding is a term you should keep in your head. It is a part of what makes polymorphism polymorphism. It is the definition that you are doing something in runtime, not in compile time. Okay, so before we go on to the last example that I'm going to do here, just to give you a quick review, let's ask these questions. So the first question is, what again was inheritance? What is polymorphism? And are they related? So inheritance, again, means that you are being able to call methods and attributes from your parent class that are exposed to you, meaning that they are public or they are protected and therefore they are allowed inside of your hierarchy. That's inheritance. There's nothing about that is changing. It's done at compile time. You are inheriting these objects because you are a child or you are extending the method that you or the class that you are extending. Polymorphism means inside the code, you are calling new on a type that is not a match of the original variable. It has to be within the chain of your inheritance. You cannot say mammal M equals new car. Assuming that car is not a subclass of mammal, that would make no sense because it has no idea what to do with that. You can't take something that's completely different and unrelated and suddenly jam it into the first thing. The things have to be related in order to do this. So if you think about like a TV show or a science fiction show, there's usually the form in many science fictions, there's some form of a shapeshifter, creature or person that exists. And they can become a lot of different things depending on the circumstance that's needed. They can shapeshift into something really small and then climb under a small gap in a door that they wouldn't normally be able to get through. And then they can shapeshift into a liquid and pour through a crack in the pavement or whatever it is. That's kind of an example of polymorphism. They have the ability to do that because they have inherited all of those capabilities from their parents. But the actual execution of it is happening when they need it, in real time, in runtime, very specifically. All right, so how are polymorphism and inheritance related? The answer to that question is you cannot have polymorphism if you don't have inheritance, because you can't change an object to something that it has no idea how to become. It has to be something that it already has inherited attributes from above. So a key part of polymorphism is that you are taking something that you have inherited from a parent or from a grandparent, and you are using that ability. So to be clear, you cannot have polymorphism without inheritance. You can have inheritance without polymorphism. Those are both true statements. You can inherit some stuff and simply just instantiate the child as the child. To go back to that previous example, I could also have said dog D gets new dog. And that's fine. And that dog will have inherited all of the things that it inherited from mammal, but it is not polymorphism. That's just inheritance. The fact that it is polymorphism is effectively stated because this type and this constructor are not from the same class. They are from two different classes, one that is inherited from the other. That's how you will always be able to see polymorphism. In your code, there will be two different things on opposite sides. This is not polymorphism because you have the same constructor and the same type on the line. If I said dog D D equals new dog, that is not polymorphism. It is just a dog that's being instantiated. The dog has inherited a bunch of stuff from mammal, but it is still just a dog. The thing that is weird is when you have a dog of type mammal. That's when it's polymorphism. So hopefully that makes sense. So the thing to look out for, you're sitting in the interview, you're sweating because it's 100 degrees and you're wearing a suit and you're thinking, I don't know why I'm wearing a suit, but here you are. And they write something on the board and they say, tell me, is this polymorphism? The thing you just need to look for is, does that and that match? If the answer is yes, it is not polymorphism. If the answer is no, then it is polymorphism. And again, you do have to be careful that on the first line they do match. It's this second line where you're using that variable that it doesn't match. So you need to actually read all the code that's on the board, not just look for that one word. Okay, so flipping back to where we were. Hopefully you can now clearly articulate these different words: inheritance, polymorphism, why they are related, and how they are different. So the next thing we're going to do is we're going to go through an example that's a little bit more real world than the example that we were dealing with mammals and dogs and cows. Because it's really cool to look at mammals and dogs and cows because it's something that we can all mostly relate to in the real world. But in reality, it's not actually very practical. You're probably not going to be coding a cow. That's not something that comes up very often. I'm not going to say it never comes up, but it doesn't come up very often. So what we're going to do here is we're going to take a game design question and we're going to actually look at some UML from a game design and talk about how polymorphism might apply here. So imagine you have designed a video game. There is a player and there are 3 different types of enemies. You have projectiles and all the other stuff. So you might have your inventory of things that you can throw and your weapons and your shields and your potions and whatever else you may have. We're ignoring all of that. So the thing is that you have yourself, which is the player, and you have these 3 different kinds of enemies. All of us are going to have to move, depending on whether this is a first-person perspective or whether this is a top-down map. What you may see on the screen, not all of them may move, but in reality, they all have to constantly move. You don't generally have bad guys that are just standing there waiting to be killed. So it's important that you have a move method that decides where each of those objects is going to go. So you may have one alien over here, you may have one bad guy over here, and in the next update, they may both move like that, and they may continue to start going in those directions, and the player's perspective may be where I'm sitting. So they're at least going to need that. Their position is going to change. You may have other things like how much health they have left, how many hit points they have, and some other stats like their strength and stuff like that. So all bad guys in this example are going to have a lot of attributes and a lot of methods that are in common. So how would you design this? Let's just talk about the enemies for a moment. So this is a very similar UML to what we had earlier when we were talking about the mammals and the dogs and the cows. But again, this is something that's a little bit more specific. So we'll start off and we'll say that an enemy is the base class. And again, this is going to be an abstract class insofar as we're probably never actually going to instantiate enemy. We're going to instantiate things that are underneath it, such as zombies, Cthulhu, and kitten. So for the enemy, we have a location, a health, the player location, and we may expose a couple of methods such as move, update, and draw yourself. All right, so let's talk about these. First thing to notice is that you've got some minus signs up here, which means that all of those are going to be private. And that's important because nobody should be directly changing the location. You should never be able to just reach in and go, poof, enemy is now on the other side of the board. That's no fun from a game perspective. Hopefully they're moving incrementally in a way that's reasonable for whatever their character is supposed to be able to do. Their health, that's pretty self-explanatory, and the player location tells you in relationship to the player where is this particular enemy, because that may determine whether or not you're going to draw them on the screen. All right, so the thing to notice is that in all 3 of the subclasses that we have down here, the methods that were defined for enemy are being overridden. We need a different move for each one of them, because the way that the zombie moves and the way that the kitten moves are probably going to be quite different. It may be that the zombie is very moving very slowly and kind of because they're a zombie, right? Whereas the kitten may be happily running across the screen very quickly, and so on and so forth. So we're going to specify how move works for each of them. We're going to give each of them the ability to draw themselves, because that's important. And then we're going to have them all have the ability to update their own individual AI, because the way that they move may change based on how the game is going. So in my game, let's imagine that I need 100 enemies. So I'm going to define an array. It is going to have 100 cells in it, and I'm going to define that they are all enemies. And now here is your example of polymorphism. What I'm putting into this array is not enemies, the class itself. I'm putting in the child classes, kittens and zombies and so on. So the first cell gets a new kitten. The type that was originally defined for this array is enemy, but I'm creating a new kitten inside of enemy 0. I'm creating a new zombie inside of enemy 1. This is polymorphism. I am putting into one type a different type that is related, that is a child. So now I'm going to say I want all of my enemies to do their thing. So it may be that each enemy has to do its own update, its own move, and then its own draw itself, which decides whether or not it wants to do it. But the key point here is, in this second block of code, I don't have to say, if you're a cat, do this, if you're a zombie, do that. I simply say, update. And the definition for zombie will be different than the definition for kitten. They will do something different, but I don't have to care about that down here. I simply say, update everybody, and they all go off and do their thing. That's the power of polymorphism. If I didn't have this, it is possible to do it without polymorphism. I could write separate code down here. This would be a much uglier block of code where I would be specifying what the kitten is supposed to do and what the zombie is going to do and what everybody else is going to do. And there may be 200 different types of enemies that I would have to write code for. And then every single time that I want to add a new enemy to the game, I have to update every block where the enemies are interacted with. That's awful. By putting it directly in the class definition, which is inheriting from enemy, I don't have to update all the code for every time that I call those objects. I simply have to update the definition in one place in the class file, and now it magically just works everywhere because I'm using polymorphism. I'm saying do update or do move or whatever it is that we're calling the method that makes the object start moving around on the screen. And the details of how that move is going to happen is all stored off in the class file for that particular type of character. So now adding a new character to the game is just as difficult as probably copying one of the other classes for one of the other enemies and then remembering to update all of the methods to reflect how this new character is going to go and making sure this new character also inherits from the base class enemy. All right? So hopefully that makes some sense. So in summary, polymorphism is a concept that you really need to understand because it explains how you can abstract away a lot of details about how subclasses and parent classes are related to each other. It is important that if you're going to use this, that all of the subclasses must override the same set of methods. So to be clear, if we talk about our cats and our zombies and whatever other bad guys we may have, it's important that they all have a move method. Because if they don't, they're just going to inherit the parent's one, and that may be okay, maybe that's what you want, but it's probably not what you want. In reality, you're most likely going to be overriding it because each of these characters is different, otherwise why do you have a class for it? A subclass object reference is assigned to a superclass base object. That's a lot of words and sounds really, really complex. It is simply what I pointed out back here. The type that you are calling when you instantiate the object is going to be of a subclass of the type of the variable that you originally used, which is going to be of the type of the superclass or the parent. Okay, that's really all that statement is saying. The superclass base class object reference is used to call the method that is overridden. So again, when you say move, you're most likely going to call the child's move in Kitten and in Zombie and in all the other bad guys. And the last statement on here is something that I've said many times. You simply cannot have polymorphism without inheritance. So there is no concept in Java, in C#, or in any of the other languages where you would be able to show polymorphism where an object is changing in real time, because it can't just change arbitrarily. It has to change to something from the chain of classes that it's inheriting from. Okay, so that is the topic of polymorphism, and that is the last of the topics this week. This is Module 3. There is going to be a continuation of Module 3 next week, and as a matter of fact, we're going to stick with Module 3 for a few weeks. You guys are going to be doing lots of examples in your labs, working with polymorphism and overriding methods inside of classes and using general inheritance. So I hope you guys are all doing great, and I will see you next week. And stay safe, and make sure you play with polymorphism and practice lots of inheriting. Bye.